Hello everyone, I am Kiran, Assistant Professor at Department. Today we will explore the core concept of theory of computation. In this session, we discuss about basic of TOC and how it is important. You can easily understand why this subject include in GATE and even in MSTCT. Following are some concepts we covered during this video, such as basic of TOC, why, where, and how TOC used, how TOC works. We will describe with real-time example using C++ compiler, what is computation, and basic terminologies used in TOC. Let us discuss one by one. All we discuss basic of TOC. TOC is a theoretical foundation of computer science. It tells us how computers think, solve problems, and what their limits are. It involves basic models like finite automata, push-down automata, and Turing machine, which help us to understand how machine compute think step by step. During this session, we understand. Move forward with another concept, that is why TOC include in your syllabus. As we know, your engineering concept is according to your IT stream, according to development, designing and defining the logic and building a machine. So your TOC subject will help us to develop logical thinking and help us to design efficient and reliable algorithm, compiler and even AI system. So where is your TOC used? In compiler design, artificial intelligence, database system, network protocols, and formal verification. While we discussing about a compiler design, what it means, the TOC concept help us to break your code into token and check your grammar. During artificial intelligence, it helps us to analyze patterns in language as we learn what is pattern designing and pattern verification using TOC concept. What is database system? Where in database system we structure and validate our queries. We wait while we work with network protocol, it means it will check if the communication structure follows the proper rules or not. During formal verification, our TOC will help us to verify the formal verification techniques to verify whether a given formatted sequence is correct or overall we can say TOC is working like the blueprint behind how everything or everyone will should work or all supposed to be how it works. Move forward. We will discuss how TOC will helpful for us. So let's describe one by one. It will improve our logic and problem solving skills. Like when we designing a DFA, NFA or a Turing machine during your TOC syllabus, you will analyze how to build a machine or how verification validation will be work in your compiler. Next, it guides us efficient software and algorithm design. As we move forward, we discuss the DFA, NFA. It will show us or it will remind us how supposed to your compiler will need to check syntax, semantics, as well as how it will work and help us for the algorithm design. Next, it is algorithm limitation, where we can check pattern given by you or given by any tape to the machine will be able to clear the Turing machine or not. Let this in your TOC subject as we discuss move forward. Now let's discuss how TOC will work with the real-time example in C or C++ compiler. TOC gives you the blueprint of how a compiler for C or C++ work from token recognition to syntax validation to problem execution with help of Turing machine. Let's discuss one by one. Lexical analysis. In lexical analysis phase, your compiler will be, your TOC machine will be generate token for each and every sentence or each and every pattern. Then syntax analysis helps us to recognize whether your code or your program is syntactically correct or not. During semantic analysis, your TOC concept helps us to know whether given program is correct logically or not. Somewhere in case syntax problem is not there but semantic problem is there like in logic. Next, code generation. In code generation, code optimization will help us to modify our code and your Turing machine will help in it. Now let's discuss next topic, that is what is computation. What mean by in TOC? Computation means solving a problem using a clear set of steps called as algorithm. For example, you write a C program to add two numbers. The compiler translates it step by step, executes it, and gives you the answer. So TOC defines what is solvable and even what is not solvable, like the famous halting problem, which is undecidable. Imagine you write a code in C program to add two numbers. You define two variables, that is a is equal to 5, b is equal to 7. Integer sum is equal to a plus b, where sum will be executable, right? Then we will print sum is equal to %d, which is class identifier for your data type \n, and your sum will be printed over here. The compiler takes the step-by-step instruction, your algorithm, and translate into machine code. This entire process taking input following defined sequence and producing an output is a computation. That is exactly what studies in TOC. How such computation are structured, what is possible and what is not. Forward with next, that TOC defines what is computable and what is not. Let's move with example. Here your example where integer a is equals to 5, b is equal to 7. In next line we do the sum, that is integer sum is equals to a plus b. Then we will print the sum value. As we see in this code, we forgot a semicolon after integer is equal to 5. The compiler will throw a syntax error. That's where TOC comes in. Using context-free grammar to define valid syntax, the compiler uses this grammar to check if your code structure is correct or not. When the structure breaks, it flags a syntax error like this. Work with another example, that is help us to classify problem is decidable or undecidable. Let's take example. In this example you can see we initialize number is equal to 8, then we will check if it is number is divided by 2, modulus of 2 is equal to 0, then print a yes and it is even, otherwise print no, it's odd. Okay, so here TOC help us to classify problem into decidable. Those we can always solve with a definite algorithm, and undecidable those we can not. Checking if a number is even is easy and always solvable. but predicting if any code will halt, that's undecidable. So TOC use Turing machine over here. As we go or move forward with TOC, we can know what is Turing machine and how it is. Next, as forward with TOC, it is important to understand a few basic terms in TOC because there are the building blocks of all formal languages and automata. Every string, language, or grammar we study in TOC is made up of symbol, alphabet, string. These define the input for machines like DSA, EDA, and Turing machine. Understanding this term helps us to define the rules, design the finite automata, and decide what strings a computer program or system should accept or reject. Let's cover some quick TOC terms. Symbol. What is symbol? Symbol is a basic character like A, 1 or 0. It is often called as smallest building block of a TOC. Here is example which is A or 1. Now what is alphabet? Alphabet is not nothing but a finite or non-empty set of symbols used to construct string and languages. As like in our Marathi or Hindi, there is a alphabet like or varnakshara we can say a, b, k. Same as in TOC, there is a, b, 1, 2, 0 or any other symbol you can use over here. What is string? String is a finite sequence of symbols from some alphabet. A string is generally denoted as W and the length of a string is denoted as W. For example like A, B, B, A. Every string is generated from your alphabet. Every string is a combination of your alphabet. Next, empty string. What is empty string? Where any of the alphabet will not present in that string or occurrence of your alphabet is 0. It is represented as epsilon. This is the symbol of epsilon. We will discuss what is language. Language is nothing but the set of valid string formatted using an alphabet. There is a two type of language in TOC. One is finite language and one is infinite language. As we move forward with TOC, we will discuss how it will be work or how it will be used. We covered basic terminologies. We move forward with quick of TOC. Theory of computation teaches us where the boundary lies, what problem a computer can solve, and what simply impossible to no matter how powerful it is. It is the foundation of compiler design. TOC is the backbone of many technologies we use every day, from how your C++ code gets compiled to how AI interprets human languages and even how database process your queries. If you are in computer science, TOC is a must. It builds the logic, depth, and clarity that every great programmer needs. It helps us to understand the core of what is computing is all about, from writing a simple program to understand the limit of what machines can do or what can not. That's it for today's video on TOC Basics. If you found it helpful, don't forget to like, comment and subscribe. I am Kiran Ghate. See you in the next one.